All right, today we're going to be looking at notes 3.2, which is operations on functions. So we've actually already explored what happens when we add, subtract, multiply, or divide a function by a number, and that was really just our function transformations. Let's do a quick review. So if we have the function f of x equals the square root of x, and we're going to find 2f of x, well, first off, remember this would be a vertical stretch because we're multiplying by a number greater than 1. And all we're going to do is literally multiply f of x by 2. And so remember, f of x is the square root of x. So instead of f of x, I'm going to write the square root of x. This is just 2 root x. That's it. If I want to divide, this is actually the same thing as 1/2 times f of x. So this would be a vertical shrink. And we're just going to multiply 1/2 times our function, or just write root x over 2, right? Because f of x is just root x, so we just replace them. If we want f of x plus 2, remember this would just be up 2. We're just going to again replace f of x with root x plus 2 on the outside. If we want to subtract 2, it's just down 2. Do the same thing we've been doing. We're going to replace f of x with square root x minus 2. And so that's all we do if we want to add, multiply, subtract, or divide by a number. And so that same sort of ideas apply if we have a graph and not a function. So let's look at a couple of examples. So we have this graph f of x, and then we're going to do stuff to it. So here we have f of x minus 3. And so if we remember, what does this do? Well, this is on the inside of these parentheses, and it's going to be opposite. So this is right, left, and if it's minus, this is actually going to be to the right 3. And so what we're going to do is we're going to pick some points on our graph. So let's take these points and sort of, I would say that these two are really good points to pick because they're like interesting points on our graph, like something is happening here. And so then we're just going to move them to the right 3. So 1, 2, 3. Our point would go here. 1, 2, 3. This point would go here. And let's look. These 2 points are connected like this, so they're still going to be connected the same way. All right, let's move this guy. So 1, 2, 3. He's going to go here. How are these 2 points connected? Well, they're connected like this. So we're going to see that same connection again. Don't forget your arrow. And then we don't really need to do this point, right? Because once we get here, we're supposed to be flat, and this guy is right here, so this should be flat. And we'll see that if we move this guy over, we end up here, and then we can connect. And so our green graph is f of x minus 3. What if we have negative f of x? Well, we got to remember what this does, right? So we have a negative on the outside, so there's a vertical flip, or a flip over the x-axis. You can also think, remember, f of x is equal to y, so we're going to make y the opposite. So let's again pick some points. Let's do those same points. And so we'll do this one in blue. So we need to look at our points. So this one is at 4, negative 4. This point is at 2, 0. This one is at negative 2, negative 4. And this one is at negative 6, negative 4. And so our new points are going to have a negative y. We're going to change the sign. And so interestingly, this point doesn't move, right? Because when we negate 0, it's still just 2, 0. But our new point here is going to be 4, positive 4, instead of negative 4. We can also think we want to go to the other side of the x-axis. This was 4 away, it's going to be 4 away. This was on, it stays on. This is 4 away, it's going to go 4 away. Or you just flip -2, +4. We only change the y. And then we have -6, +4. Then we got to connect. This is a straight line. This connects to this guy, and then we go that way. So this is what it would look like if we flipped. It's our green graph. Let's do 2 more. So this one we have 2f of x. This is kind of interesting. So this is a vertical stretch. But we're just going to multiply our y by 2. So let's look at our points again. So we've got 4, -4, 2, 0, -2, -4, and -6, -4. And so we're going to multiply our y by 2. So interestingly, this guy stays the same, because it's 2, 0. 0 times 2 is 2. So here we have to change, this is going to be 4, -8, because we've got to multiply that by 2, and so that brings this point all the way down to here. We do the same thing over here. We get -2, -8, and -6, -8 when we multiply all of our y's by 2. Then we just connect, and we can see the slopes of these lines have gotten steeper. All right, let's do our last one. So for this one, we have a -4 on the outside, so this means we're moving down 4. So it just means we need to take all of our points on our graph and move them down 4. We can just count this. 1, 2, 3, 4. It's going to be here. This point. 1, 2, 3, 4. It's going to be here. We can do this for all of our points on our graph. 1, 2, 3, 4. That one's going to be down there. We'll count this guy down. 1, 2, 3, 4. It's going to be there. 1, 2, 3, 4. Right, and once we have enough points, we can just connect our graph. And so this would be our graph down 4. So we can add, subtract, multiply, or divide. Dividing would be just like this one to move even our graph. So the next question is, what happens if it's not a number? What if we're adding or subtracting a function from another function? So we're going to look at a bunch of examples. So in our first examples, we're going to have f of x be cosine of x. This is a graph we're going to explore a lot later this year. And g of x equals 2 to the x. We should have seen that graph before. 2 to the x is an exponential graph. And you might have seen cosine before. Cosine is what we call a sinusoidal graph. It comes from our trigonometric functions. Sometimes we call them waves because it looks like a wave. So if these are two functions, I'm going to go ahead and call them f of x and g of x in Desmos. So we can sort of follow along in Desmos as well and look at some of the cool functionality that Desmos does. All right, so those are our two functions. If we want to add them together, it might seem intimidating, but all we need to remember is that this is f of x and this is g of x. So where I see an f of x, I am going to put in cosine x. Then we have a plus, and then I have a g of x, 2 to the x. And that's it. That's my answer. And so in Desmos, we can actually just do this as f of x plus g of x. And Desmos is smart enough that it actually knows what we're talking about, and it will do it for us. So we get this weird squiggly exponential graph. Sort of combine their behavior. And so if we graph what we got, so cosine x plus 2 to the x, we get the exact same thing. Notice they overlap. That black and purple function overlap because they're the exact same thing. So this is a good way to check what we're doing. So what if we want to subtract? All right, so we're going to do the same thing. When we see an f of x, we're going to put in cosine. So we have cosine x. Then we have a minus this time. Then we see g of x. Well, that really means 2 to the x. So we have 2 to the x. And so in Desmos, we can change this to a minus. And so then we see this, which kind of makes sense, right? We like flipped the exponential part of the behavior. Watch. Exponential goes up, exponential goes down. It makes sense because a negative flips the graph, right? So it's sort of logical what we're seeing happen here. Whoops. And then in Desmos, we can check. Let's check that what we wrote is correct. We have cosine of x minus 2 to the x, and they line up. So we got it right. Okay. So now let's look at the order. What if we change the order? What if instead of having f of x first, I do g of x first? Well, that would be 2 to the x. Then we have a plus sign. Then we see f of x, which is cosine x. So we write cosine x. And so let's see what the difference is. So let's make this go away for a second. We'll add another one. And we're going to put in g of x plus f of x. And so notice that it's actually not any different than f of x plus g of x. And so these two things are the same. And so that's always going to be true. That is due to the fact that addition is what we call commutative. Commutative sounds like a really fancy word, but really just focus on that commute part. Commute means to go somewhere, to move, and so what it means is that order doesn't matter for addition. Doesn't matter what order we do it in, we get the same answer. So now take a second and think. Is that going to be the same for subtraction? Think about what you know about numbers. Does the order in which we subtract matter? Well, let's try it. So we got our g of x first, which we know is 2 to the x, because that's what it told us. Then we have minus this time, our f of x, which is cosine, so we cosine x. And so when we put that in, let's look at this new one now. So we have g of x minus f of x, which looks like that. And if we look at our original, so our original looked like this. Are they the same? And they're not, right? But there's something sort of interesting happening. They're like reflections of each other or flips of each other. And that makes sense if we think about numbers, right? If we do 2 minus 4, that gives us negative 2. If we switch the order, we get 4 minus 2 equals 2. It's always a different sign. So we see a change of sign when we change the order. And so what we see in our graph is that we get a change of sign in that we have a flip, right? We talked about that earlier today. It's not the same. They are flips of each other. That's because subtraction is not commutative. Order matters. Okay. So let's do some more practice. This time we're going to look at two polynomials. We'll bring Desmos back in a second, but let's try it without Desmos. All right, so we have our function f, which is 2x cubed minus 4x plus 1. So each of these f's is going to get replaced with that. And then we have our g. G of x is 4x squared plus 5x plus 6. And so this is part of the reason why we give them different names like G and F. That letter outside really is an identifier. It tells us which function we're talking about. Inside the parentheses tells us what variables we use. So like P of S, S would be the variable in our polynomial, or our whatever function we're looking at. All right, so let's put our F in. Let's do this first one. So F, I'm going to make sure that I put it in parentheses. And that's going to be important. We didn't do that in our last one, but also our last one, our functions were only one term, so parentheses doesn't really do much. But here we have something more complicated, so I am going to put it in parentheses. Then we have plus, we've got our g of x, 4x squared plus 5x plus 6. Now, because we're adding, we should know that when we add polynomials, we can just sort of drop our parentheses and we just combine like terms. Because we want to simplify. So we've got a like term in our x's, and we have a like term in these constants. And then we just traditionally want to write it highest power first. So we're going to start with this 2x cubed. Then we're going to go to our x squared term. Combining these, we get just x. And then we have plus 7. So this is our f of x plus g of x. Okay, we'll come back and check each one of these later. Now, I can already do c, right? It's the exact same thing. Why do more work? Let's be smart about it. Paste. Done. It's going to be the same. All right, so let's look at b. So we're going to take f of x. That is 2x cubed minus 4x plus 1 in parentheses. Then we're going to subtract g of x, put it in parentheses, 4x squared plus 5x plus 6. Let's zoom in on this guy. And here's where that parentheses becomes super important. It's really in the subtraction. This minus has to go to each of these terms. So then we have 2x cubed minus 4x plus 1 minus 4x squared minus 5x minus 6. Make sure you're doing correct polynomial subtraction when you do these things, and that we are subtracting each of those terms and not just sort of ignoring that subtraction. Once we get here, we're going to combine like terms just like last time. We still got x's in common, and we've got constants to combine. Oh, let's do not that color, I already used it. All right, so highest power first, 2x cubed. Then we've got minus 4x squared. Combine our x's, that gives us a total of negative 9x. Combine our numbers, and we get minus 5. This is our polynomial. Okay, let's try switching the order. So we're going to put g, which is 4x squared plus 5x plus 6 first. Then we are going to subtract f of x, making sure we put it in parentheses, 2x cubed minus 4x plus 1. Got to make sure that we subtract, so we need to change all of these signs, and then we can get rid of our parentheses. And so when we do that, we now have 4x squared plus 5x plus 6, nothing changes in here, and then we have minus 2x cubed plus 4x minus 1. And now, like before, we are going to combine our like terms. So we've got our constants, and we've got our x's. Highest degree term first, that's over here now. So negative 2x cubed, then we put our square plus 4x squared. Combine our x's, we get plus 9x. Combine our constants, and we get plus 5. Now let's take a look at what happened. So these were our two subtractions. And if we notice, 2x cubed, negative 2x cubed. Negative 4x squared, positive 4x squared. Negative 9x, positive 9x. Negative 5, positive 5. Like we saw earlier, it's just a difference of signs. All of our signs change when we flip the direction of our subtraction. All right, so now that we've got these, let's check them, because that's the nice thing about this is we can check using Desmos. Oop, I didn't mean to do that. All right, so let's put g of x in. This time g of x is 4x squared plus 5x plus 6. Let's put f of x in. F of x is 2x cubed minus 4x plus 1. All right. So now let's do this. We're looking at f of x plus g of x first. So this is what Desmos says it is. Let's check our answer. 2x cubed plus 4x squared plus x plus 7. Oh, yep, they line up. We're good. All right, so now let's check f of x minus g of x. This is b. Let's put in our answer. This is what Desmos says it should be. 2x cubed minus 4x squared minus 9x minus 5. And look, they line up. So we're good. We could also check the last one, or since we verified that we did see a change of signs, that's another way. We've sort of already checked that one. All right. Now something to know is we don't always see it written like we saw it here. Sometimes we'll see this notation. We'll see f plus g of x. That's how we read that. F plus g of x. Or we might see f minus g of x. And we could see the same thing. We could see like g plus f of x or g minus f of x. It doesn't matter which letter is where. So really these are the exact same thing as the stuff we've done before. It's just a sort of compact notation. This is the same thing as saying f of x plus g of x. And this one is the same thing as saying f of x minus g of x. They're the same thing. And so like here this would be g of x plus f of x. And this would be g of x minus f of x. So it's just a notation thing. We might see it either way. Just depends. So what about multiplication and division? Well, they're new operations, but like they don't do anything different. We're just gonna multiply, we're just gonna divide. So let's practice. So we're gonna do the same thing we did before. What is f? Well, f is x squared plus 4x plus 4. So that's what I'm gonna write. Instead of f of x, I'm gonna write x squared plus 4x plus 4. And then instead of g of x, I'm gonna write x plus 2. So times x plus 2. And now I just need to follow whatever like operation I need to do for multiplication. So here we're going to distribute, right? We're just going to multiply everybody in the first one by everybody in the second one. So we're going to do x squared times x. That's x cubed. X squared times 2. 2x squared. You might do this with the box, and that's fine. Doesn't matter. Then we would have 4x times x. That's 4x squared. Then we have 4x times 2, 8x. And then we got to multiply our 4. 4 times x, 4x, 4 times 2, 8. And so when we do that, we end up getting x cubed. Gotta combine these two. 6x squared. Combine these two. 12x and plus 8. And then we can check it. Let's check. Oh, let's keep that. So our f of x is x squared plus 4x plus 4. G of x is x plus 2. Then we can just change this 2 times. And then we'll put in our graph, we got x cubed plus 6x squared plus 12x plus 8. Yep, all good. All right, so let's do one more. So for this one, we're going to divide. Now for right now, all we can do is replace these. We're going to learn a little bit later this unit how to keep going from here, but for now all we're going to say is this is x squared plus 4x plus 4 divided by, we're going to put g of x plus 2. And we're done. And so something interesting is going to happen when we look at this. So we're doing f of x divided by g of x. G of x. I'm going to delete this guy. Notice we got a line. So what that tells me is that I can simplify this fraction, and we're going to learn how to do that in our next set of notes. But we can check that what we've written right now is technically correct. It might not be the simplest way we can write it, but it is actually like still true. So if we do this, oops, divided by x plus 2, we get that same line. All right, so that's addition, subtraction, multiplication, and division. We can do 4 options now between functions. And just like with addition and subtraction, we get that same sort of different notation. We're going to read this one as f times g of x. This one is f divided by g of x. And it really is just f of x times g of x. And this one is f of x divided by g of x, or you can write it as f of x divided by g of x. It just saves a little bit of space when you write it out if we don't have to write that of x twice. Now the big thing we're adding now is a new operation. That new operation looks like this. And so this looks scary, but it also looks exactly like stuff we've seen before, right? If we just do this, right, I can make this go away. And then it's just f of something, right? Well, it's f of what? It's f of g of x. So we would read this as f of g of x. This operation is called composition. It's called composition because we are putting functions together. It's a function made of functions. So now really quickly remember, what does f of 5 mean? It means we're going to plug in 5, right? For x. So then it follows from that f of g of x, well, g of x is the thing on the inside just like 5 was. It means we're going to plug g of x into f of x for x. Means that every x we have in our equation becomes a g of x. So it's a way for us to substitute expressions instead of numbers. So we can substitute expressions instead of numbers. Okay. Our notation for this it sometimes looks like this. Don't read this as fog. This is just an open circle. We read this as f of, think of this as the O in of, g of x. So this is the same thing as f of g of x. It's just a different way to write it. Sometimes you might see these things without the x. You might see it just like that, or like this. We can also have more than two. We could do like f of g of h of x. And so we just read that f, then we say of, then we say the next one, of h of x. And so the key when we're doing these things is to work inside out. So we would find g of h of x by plugging h into g. Then we would plug that, whatever we get from here, into f of x. So we work inside out. Okay, so let's do some practice. So let's say that f of x is square root x. So f of x is square root x. And g of x is 2 plus x. Right, so our first one says f of g. So this is f of g. So that means we're going to put or plug g into f. So f of x, let's just remind ourselves, f of x is square root x. So I am looking for f of g of x. So that means I'm going to put a g everywhere I see an x. So this is the square root of g of x, right? But g of x is 2 plus x. So that means that f of g of x is actually the square root of x plus 2. All I did was plug g into f. What if we do it the other way around? What if we do g of f of x? Right, that's what this one says. So f is going on the inside. So we're going to plug f into g. So let's remind ourselves we need g first. So g of x is x plus 2. And so we're going to put f of x into that because we're looking for g of f of x. Right? So that means that we're putting f of x everywhere we see an x. So we're going to have f of x instead of x, and then we're going to have plus 2. But f of x is really square root x. So that means that this is g of f of x is equal to the square root of x plus 2. So this is really just substitution. And notice these are not the same. So what that means is that you need to be careful. Order matters with composition. It matters who you plug in to the function. You need to know which is your outside and which is your inside. The inside one is the one you plug in. We're going to end with just 6 more examples so we can practice this. And we're going to look at some of those three guys. We're going to plug it. Actually, we're going to look at all of 3s so we can practice this. All right, so we are going to work inside out. So we're going to do this first group. So we need to find g of h of x. Well, the first thing to do is identify our functions. So g is the absolute value of x, and h is 2 to the x. So I'm plugging h into g. Another way I could write this is I could translate this. I could go ahead and, ooh, let's not do that color. Let's do a different color. Let's do purple. So I can go ahead and translate this h. This is g of 2 to the x. So that means I'm going to put 2 to the x everywhere there's an x in g of x. Well, this is g of x. So that means that this 2 to the x is going into this x. So that means that this is the absolute value of 2 to the x. So now I need to plug that in. Plug, well, we just got it, absolute value of 2 to the x into our outside function, f. So we now need to find f of the absolute value of 2 to the x. That's because the absolute value of 2 to the x is this whole thing. So what is f? Well, f is this guy. So that means we're plugging in, let's write that out. So f of x is equal to x squared. So if we're plugging this in, means that we're plugging the absolute value of 2 to the x into x. So that means we're going to get that f of g of h of x is equal to this guy, absolute value of 2 to the x squared. So that's our final answer. Let's look at number 2. So number 2, we have that different notation. Well, let's translate this notation. So we have f of g of h. That's going to be of x. So we got to close it. Notice this. This is exactly the same as this. Why would I do it again? I just need to know that those are the same thing, and then I'm done. Boom. If we can translate, then maybe we don't have to do anything. We just need to know what our notation means. Okay, let's look at our next one. So for this one, we have sort of a mix of those two notations, which is fine. We have g of h of f of x. Gonna work from the inside out. So that means we're gonna do this guy first. So we need to find h of f of x. So that means we are plugging f into h. Well, h is 2 to the x. And so we're going to plug f of x into that x. And f of x is x squared, right? Because it says it up here. So instead of x, I'm going to have x squared. So that means this is 2 to the x squared. So that's h of f of x. Now we need to plug that into g. Plug into g. Well, let's remind, what is g? G of x is the absolute value of x. So we're going to plug this into x, everywhere there's an x. And I only have one x. So now we have our whole thing. G of h of f of x is equal to the absolute value of, we got to plug our thing in, 2x squared. That's what we get. All we're doing is fancy plugging in. That's all composition is, just substitution. All right, let's look at our next one. Here we've got h of g of f of x. Close everything off. Got to work from the inside out. First thing we're going to do, g of f. So have we done g of f yet? Nope. So we got to do it from scratch. So we're plugging f into g. Well, g is absolute value of x. F is x squared. So we're putting x squared into absolute value. We're putting x squared into absolute value, right? We're plugging f into g. Now we gotta plug that. Plug absolute value of x squared into h, because that's on the outside, and h of x is 2 to the x. So that means that instead of x, we're going to have absolute value of x squared. And so our result for h of g of f of x is 2 to the absolute value of x squared. Two more. So for our next one, we have g of f of h of x. Close it off. So we got to do our inside first. Inside is f of h of x. We haven't done that one yet. So we got to find f of h of x. So that means we are plugging h into f. So it means we're plugging 2 to the x into x squared. So that means we have 2 to the x squared, which is really just 2 to the 2x, right? Really quick side note, this is not the same as this. Here we put a square into the exponent. Here we squared something with an exponent. Those are two different things. Be careful with that. All right, so once we've got this, we need to plug what we just got, which is 2 to the 2x, into g of x, which is the absolute value of x. So instead of x, we're putting in 2 to the 2x. So that means that g of f of h of x is equal to the absolute value, plug it in, 2 to the 2x. If we had more than one x, we would need to replace both, but for these we just have one x. Last one. So this one we're doing h of g of f of x. Now, we actually have already done this one, right? This is the same as this. Same notation. I don't have to redo it. It's exactly the same. This is the same as number 4. Just with different notation. Okay. So that's our function composition and our function operations. And we'll do more practice in class.